So, what we have here, we have two cars with the same mass. And in order for this car to start moving, I need to give a little push, right? So if I do that, this car is going to move with a certain velocity. The question is, when the car hits the other car, what's going to happen? Well, there are two situations here. One is that the car is going to hit this one and it's going to transfer its velocity to the other car. That's one situation. The other situation is if the car hit this one and get stuck together and they move together. So what do you think is going to happen to the velocity then? What is going to be the relationship between the initial velocity and the final velocity with both cars moving together? That's one question. The other one is that if we think about linear momentum, right? Linear momentum is the combination of the speed and the mass of the object, okay? So what's going to happen to that? It's going to be conserved or not? But that's linear momentum. So let's see what happens. I'm going to do a little push, and let's see what happens. And you see, let's repeat that so you can see that again. So observe at the velocity of the initial car and then the final velocity. I think it becomes clear that the velocity has reduced. Well, the mass has doubled, right? So the velocity should be what? Half of it, right? Okay. Now, what I really want to show is when we have now circular motion. So I have here a disk of a certain mass, and I'm going to initiate some rotation here. How can I initiate rotation? Well, remember here, I applied a force, but this is linear motion. In order to get this disk to rotate, what is there I need to apply here? A force? Is a force alone going to work to start rotating the disk? Well, depends where I apply the force, right? If I apply the force here at the edge, yes, it's going to start rotating, right? But if I apply the force here in the center, right, line up with these axis of rotation, what do you think is going to happen? Is this going to rotate? Let's see. If I push it, well, that's not rotating, right? Okay. Now my question is, if I get this to rotate at a certain angular speed, and I have here a second disk with the same mass, and I let this sit here, exactly at the same location, what do you think is going to happen with the angular speed? It's going to be the same, it's going to increase, or it's going to be less, right? And then how much less? The mass is the same, so it's similar to what happened here, okay? So let's see if I can do this experiment. So it's rotating at a certain speed, and it's going pretty fast. I hope you can see it. So I'm going to let it sit this right now, and I think it was clear that it slowed down, right? You can see that? It's slowing down. So I'm going to remove and do it again. And it's going really fast. You can see it's going really fast, and now I'm going to let it slow down again.